All right, so when I think about this visual pattern, here, this is my approach in how I would go about answering the question. So when I look at the pattern, this has colors, so it's helpful. So I'm like, okay, what is staying the same? And when I look at the pattern, I notice that this yellow region happens to be the same in um, all the stages. So that yellow piece, which is a +2, happens to be the same. Um, what's changing? When I look at what's changing, my green section is growing and it's getting bigger. But I notice, oh, this is 3, that's 6, this is 9, that's 12. So I notice that green portion is changing. And also, what's a type of growth? So we're going to look at what's a type of growth. So these are the questions that come up in my head. And then the last thing is like answering that last question. So what is wrong with this thing? So here's what I'm going to do first. I'm going to look at the total number of squares in each. So the first one has 5. The second one has 8. The third one has 11. And the fourth one has 14. And if I'm checking that out, here's what I'm noticing. To go from 5 to 8, that's a +3. And I'm seeing this additional 3 right here. To go from 8 to 11, that's also a +3. So here is where the additional 3 was added. And then to go from 11 to 14, that's also a +3. All right, here's where the additional 3 was added. Another thing I'm noticing is that that yellow portion that stays the same, I can refer to that as a +2. And that's going to be constant. And for the portion that's changing, I notice there are actually multiples of 3. So the first one is going to be 3 times 1. The next one is 3 times 2. This is going to be 3 times 3. And this one is 3 times 4. All right, so that's going to be equal to 3. That's equal to 6. That's equal to 9. That's equal to 12. So if I'm trying to write an expression, which we're eventually going to get to, I know that this is going to be 3 times n, where n represents a stage. So this is stage 1, stage 2, stage 3, stage 4. The type of growth, because we're constantly adding the same number, we notice that that would be a common constant rate. So this is a linear growth. The expression that would be given here would be the expression 3n plus 2, and it's, or 3 times n, which comes from how our green section is growing, and our +2, which is a yellow, which is constant. And then they asked us, like, the 5th stage, so stage 5, what would we end up getting for stage 5? We're going to get 2 of those yellow pieces, and then that's going to grow. So that's, we're going to have 5 of these. So that's 1, 2, 3, 4, and then last piece, that's 5. So how many squares would I have in total? That's 5 times 3, that's 15 plus 2, 17. So that would be a total of 17 squares.